my project from last year that I did in Weißensee in the greenlab project. It's called Cladophora. And so to just give a little introduction into the problem that I was basically dealing with or researching on. This is a picture of the Lake Erie in 2 years, so in 2013 and in 2018. And you can, I think, quite clearly see already the problem that I was researching about. So that actually, and I think, or it is not just this lake, but actually all around the globe, that the water quality of lakes is changing, and that instead of having a blue water surface, you will more often see it turning into more green. And this is a graph from the European Commission of Fresh Water. And here you can see quite well on the right side, there's that in 2010, when they start actually measuring the water qualities of the European lakes, that more than half of the lakes is not having a good water quality. So they set a target to 2015 and try to get all the European lakes onto at least good water quality. But as you can see here quite well, I guess that in 2015, the water quality even became worse. So more and more lakes are suffering from bad water quality. And in the end, they try to, or they set the target on 2027 and still trying to kind of reach this goal. But for now, it doesn't seem that it will work until then. And so one of the main contributors to this water crisis, let's say, in the fresh waters is mostly algae. So here I just show you 3 of the, let's say, main ones causing this so-called eutrophication or tip over of the lakes. So it's the Cladophora, which is the one that I was in the end working with. Then we have the Spirogyra and cyanobacteria. And yeah, they are kind of covering the water surfaces of all these lakes. And what's actually the problem about it, because probably we all know that algae in general is something good and is necessary in the lakes. But due to human activities, which I will explain later a bit better, the algae bloom is basically uncontrolled at the moment. So on the down graph or line, you see how it's supposed to, or the cycle of the year where the algae is supposed to work. So in spring, the algae would start growing, and then around October or autumn, there is a bacteria basically eating up all the dead biomass. And so during the winter period, we would not have any kind of algae basically left in the lakes. And then in summer or in spring, the algae starts growing again. And what we actually have at the moment in a lot of lakes, I think really all around the globe, is that the algae is even more. There's more and more algae growing. So in summer we have masses, tons of algae in the lakes. In autumn, when the bacteria try to eat up all this biomass, it's basically impossible because there's so much biomass left. So what they do, of course, they are trying, and they need a lot of oxygen to kind of break down the biomass. So this oxygen is missing for fish and other living beings in the water, and so causes, for example, the death of fish. And this eutrophication, basically is this kind of process. And so in winter, we will still always have some algae left in the lakes. And next year, of course, we will start the year with another bigger amount of algae. Thinking, so what's basically, why is it happening? And why is there always more and more algae coming up? And this problem is just getting bigger and bigger. Basically, human activities are responsible for this algae growth, because of course there's the climate change. Algae love warm water, warm weather. So that's one thing that causes it. Then we have the rainwater, we have a lot of wastewater as well. And of course, if we do overfish the waters, there is no fish eating algae anymore. Let's say the main problem is actually the agriculture. So by with the cows and also for vegetables and fruits, because we are of course always trying to fasten up the growth process and therefore use a lot of fertilizers, which in the end basically enter all the lakes through the groundwater and give a lot of nutrient oversupply to the lakes. And of course the textile industry is part, with their crops on cotton and everything, is also part of this agriculture sector, let's say. And as we all know, our fiber demand, or the most common fibers that we're using for our textiles, are either water polluting polyester or chemical fibers, or we also have the cotton, which is amazingly water consuming. So after all this information, I basically thought, okay, we have, on one hand, we have this current textile industry problem that we are actually polluting and consuming a lot of water when we produce or use the fibers. So, and we basically, on the other hand, have this this algae, which is a side effect of all these kind of industries of agriculture. And then I thought, I mean, why maybe couldn't we use this kind of problem of water crisis to get it or to become part of its solution. Basically went to a lot of lakes in Berlin, around Berlin, also in Hamburg, and I harvested the Cladophora, and it's actually a really nice algae because also the name tells it, it's a filamentous algae, so it's basically from its natural origin appearing in fiber-like form, so they have long, very fine fibers, let's say. And I realized that depending on the lake, on the water quality, maybe also on the depth of the water, you will always find different kind of qualities of this algae when you dry it. So there's some that is really amazing and really feels like wool, like felted wool kind of. But of course, then there's also the already dead and broken down algae leftovers that's mostly on top of the lake surface. But for me, it was still important kind of to try to use all this kind of qualities to do my project and to create textiles from it. Because I mean, we have to get the lake, let's say, back into their balance, we have to harvest all this kind of algae. So not just the nice quality, let's say. And here you can see the photo of the qualities. From 3, which is really looks like a paper clay kind of thing, and the quality 2 is short fibers but still quite soft, and then we have the quality 1, which is a really soft woolen material. So with the quality 3, I started thinking on how can I give it back or bring it back into a kind of surface. And of course, with this broken small pieces, it's not possible to just like this create a textile. So I use this kind of bioplastic techniques with the glycerin and gelatin or agar-agar, which is another kind of algae, to create this different kind of materials. I don't want to go into this too much. And here you can see, depending, let's say, how much algae you add, you can get really different kind of textures, also different strength and flexibility in it. And it's also possible to make patterns or different kind of shapes depending on your mold. And it's also possible to weld it, so to create this kind of patterns. And to go to quality 2, which is the kind of short filaments or short fibers, I'm kind of made use of the non-woven technique, of course, on a lower level, but I kind of use the screen printing frame and try to kind of reconnect the algae on the surface, and then through the water pressure basically create yeah, this kind of non-woven materials. Oh yeah, well, and you can really, I just added them behind each other, all these sheets, and you can create really like a meter long fabric. And yeah, and so the best quality is my quality 1, which is really long fibers. So basically the algae can have up to 2 or 3 meter long fibers, depending on how old they are and how well they are. So what I did, I built my little yarn spinning machine, and yeah, and really created a yarn from the material. I think you can see really well how soft it is. And yeah, so it was basically possible to make a yarn from it. Yeah, and then of course for creating a surface, I tried different techniques, but actually the knitting did not work too well, because you make all these hooks kind of, and they sometimes broke the material, but the weaving worked really well. So I just went to Weißensee and made the, yeah, kind of a long carpet from it. This is the resultant yarn, and here you can see the woven fabric that I did. And some smaller samples, so with different kind of weaving techniques. And one interesting thing that happened without me noticing it, actually, just in the end, is that the color of the material is changing. So this where I started weaving, and it was in summer, so there was a lot of light coming in. Yeah, turned into this kind of more bluish, whitish kind of color. And in the end, you can still see the really big green. And first it was, yeah, I was a bit sad that this happened, but in the end I thought maybe it's also a good thing that basically your fabric can change yeah, over time, and kind of has its own life, let's say. And just quickly wanted to show you another idea on, so I thought, okay, if in case we would kind of replace, let's say, all our cotton with algae fibers, then of course at some point there will be the problem that there's no algae left in the lakes, which also shouldn't happen, because then again we would kind of get the ecosystem out of balance. So I created created a tool for my spinning machine that actually makes it also possible to grow the algae inside. And here, just to show you, we did experiments in the lab at the University in Berlin.
I think it's important to work on visionary projects like that. And I think it's understandable that you as a student within, I mean, you're not an institute, not a test company, and some thinkers have to run, think in the future and invent visionary materials without, commercializing the entire idea, without testing the entire idea. I think this is up to, sometimes this might be up to then textile engineers and companies who will take up the idea maybe in the future, or even people who would like to collaborate with you or interested to research this aspect of an algae fiber. Maybe somebody is interested to research how the fiber can be cleaned, how it's durable in the long term.